Let's understand significance level. When we do scientific studies, we want to be confident about our study and findings. So the more confident we are, the better the study is. So the confidence level, if it is 95%, then the significant level is given by alpha and it will be 1 minus 95, which will be 5%. Likewise, if we are 99% confident, that means, the significance level will be 1 minus 99, so it's 1%. So there are three possibilities that can happen in our hypotheses studies, right? So we can have, let's say that in this example, we want to say that mu value, the mu, which is the population mean, is less than 5. So we start with the null hypothesis, which is mu equal to 5. The alternate is mu less than 5. So when we look at the distribution, the normal looks like this. So because this is a, because mu is less than 5, it's a left tail test. Okay. And it's a one tail test, right? Because it's only happening in the left. That means that there is a 95% area in which we accept the null hypotheses. Okay. And there is 5% region where we reject null hypotheses. Okay. So that means that once we find the test statistics, and if the test statistics falls here, right, and this will be the p-value, right? Okay. And so this is how the significance level is used. If the p-value, whatever value we get after getting the statistics, if it is less than 0.05, then we are in the reject null hypothesis region. That means that we are going to accept the alternate hypothesis. So this is a very important concept. All right. So when do you reject null? When the p-value you get from the test statistics is less than the significance level of 0.05. Okay. Likewise, we can have a right tail test. That means that we want to say, our goal is to prove that mu is greater than 5. Again, the null is mu equal to 5, alternate is mu greater than 5. And this is a right tail test, one tail test again. And so, we have the region where we accept the null hypotheses. And this is 95% because the significance level which are choosing is 5%. And then we have the H0 reject region. So if we get the p-value, if the p-value is, the test statistics here and the p-value is here, that means that we are going to be in the reject null hypothesis. However, if the p-value is here, right, the statistics is here, the test statistic, and then the p-value we get is, I'm just going to use the red here, right? So that means that for this example, the p-value is actually greater than alpha. Then we cannot reject because we are in this H0 accept area, right? So if this happens, then the conclusion is that, if this happens, that the conclusion is that, we have to accept the null hypotheses. Okay. Then the last case is when we are just saying that mu is different than 5. We are not saying whether it's less than 5 or greater than 5. We are just saying that mu value is not equal to 5. We form the H0 as mu equal to 5. This is called a two-tail test. And notice that in a two-tail test, this 95% lies in the center, right? And the alpha is same, alpha is 5%, but however, we have to kind of break it down into, half of the alpha will go here, half of the alpha will go here. So we have alpha over 2, alpha over 2. So we have H0 accept region, and then we have H0 reject region here and here, right? So let's say that, we get the p-value, test statistics, and then the corresponding p-value, and p-value is here. If the p-value, whatever we got, is if it is less than alpha over 2, that means that we reject the null hypotheses. Okay. Reject null means we are accepting the alternate hypothesis. So this is how, the significance level is used with respect to the p-value.